Alright, here's the first video on multiplying and dividing fractions. So this is a blast from the past way back to 6th grade, but nonetheless people are generally fuzzy on this type of topic, so we're going to cover it in depth. Alright, if you're multiplying these fractions, there's a couple of ways to do it. We got 15/17 and 34/20. You can throw this in your calculator, but that's not going to help because when we get to work with polynomials, it's not going to be so fun. So just to give you a flavor of what we're going to be doing is instead of multiplying numbers, we want to multiply things like x squared minus 4 over x plus 3 times x squared minus 9 over x to the 5th plus 32. We want to multiply those and simplify those. So when we're looking at multiplying fractions, we want it from the lens of completing problems like this. So things like throwing it in your calculator and then pressing math fraction are not going to work. For the simple reason that your calculator, if you haven't noticed, doesn't do everything for you. And goodness, I hope it never will, or else none of us are going to be useful, and then we're going to be starring in the real-life version of the Terminator movies. Yay! End of civilization as we know it, thanks to your calculator. Okay. Couple ways to do this. You can multiply across and then factor, but honestly you're going to get a larger number to factor. So what we want to do is factor first. And a lot of you are going to do this in your head. You're going to see 34 over 17 and realize, wait a second, 34 is double 17, so we can divide both those by 17. So that's 2 and 1. Then you look at the 20 and the 15. Well, those are both divisible by 5. So that's a 3, and that's a 4. So what we say this is 3 times 2 over 1 times 4, which is 4. Well, my friends, 2 divided by 4 is 1/2. So that gives us 3 over 2. Isn't that exciting? But let's back up. There's a level of intuition here where you look at those numbers and you automatically know, well, 15 is divisible by 5, and we can. It's pretty easy. Well, let's back it up a little bit. Hold the phone. If we're looking at this problem, x squared minus 4 over x plus 3, it's not particularly clear right away what factors are available. So we're going to need a more algorithmic way to deal with this until you are a savant with factoring. So let's take a look at these two again, and let's do it in the really boring way. We are going to write the prime factorization. Alright, and now is the time where you can make fun of my handwriting. Yay! So, we're going to prime factorize every one of these. So 15 is 5 times 3. 17 is prime. And just remember that prime just means that we can't factor it anymore. And then 34 is 17 times 2 over 5 times 2 squared. Right? Because 5 times 4 is not prime, so we're going to write that as 2 squared. Now, the best part of all of mathematics, the massive cancellation. Now notice, what we have here is division signs and multiplication signs. You may know that division undoes multiplication. This is critical. Because if there's addition, we run into problems, and I will show that to you very shortly. So you can't just cancel everything. Don't be lazy. But we can cancel here because all we have is multiplication and division. So I look. There's a 5 and a 5 that cancel. There's a 2, and one of these 2's cancel, leaving me with 2 to the first power, not 2 to the second. The 17's cancel, and we're left with 3 over 2. That is the prime factorization method. And notice it is exactly the same as the last videos or the last slide's method. However, it's more algorithmic and more procedural. Now let's take a look at 3 plus 5 over 5. The question is, can we cancel the 5's out? Notice this is not written in factored form. It's not like a times b or 3 times 2 or, I don't know, maybe x plus 1, pardon me, x plus 1 times x minus 3. Notice how those are factored. You have one item times another item, and that's it. Inside the item, we don't care, but we're looking at the relationship between those two items. So in this problem, the relationship is addition. Division does not undo addition. And I know you're going to make this mistake because no one ever listens. In the history of every math teacher, they've always said division never undoes addition. And yet kids think it does, which I don't understand. And let me prove it to you. If you do 3 plus 5, that's 8 over 5. If you cancel the 5's, you get 3. Right? So 8 divided by 5 is not 3. 8 divided by 5 is 1.6. Those numbers are not the same. So that everything needs to be perfectly factored. For example, when I say factored, everything is multiplied. So maybe 3 times 5 times 2 plus 7 over 7 times 8. Is this factored? No, because there's addition. Now let's take a look at another problem. Is this factored? Well, let's take a look at maybe 3 plus 7 times 2 over 4. Well, yes, this is factored because you can write this as one item times another item. Here, on the left side, there is no such way to rewrite that problem as one item times another item without performing some further procedures. Last part is division. Let's take a look at 15 over 17 divided by, let's say, 20 over 34. Well, with division, the second fraction reciprocates. This is from way back in 6th grade, people. 15 over 17 times 34 over 20. Done. And notice we've already solved this problem, so we don't need to do that again. Already did. Alright, hopefully this video was helpful for you. Tune in next time, which is in like 2 minutes when you click on the next link. Goodbye.